All right, how's everybody doing today? We got another exciting lecture going on here. We got percent yield. That's just one more step on to the stoichiometry that we were doing. So let's get going. So the last couple of days we've been doing stoichiometry problems. We've been going from mole to mass, mass to mole, mass to mass. So what we're going to do today is we're going to add one more little step. And that step is to eventually find a percent yield. But before we do that, we got to talk a little bit about the theoretical yield. Now it says here that the theoretical yield is the maximum amount of product that can be produced from a given amount of reactant. Now, we've already solved for this when we've been doing these mass-to-mass problems. Essentially, whenever we go from a mass of one thing to a mass of a final thing, something different, that's the theoretical yield. So there's no new fancy calculation or anything when we do theoretical yield. Again, we've already been doing it with a mass-to-mass relationship here. Then it says a chemical reaction rarely produces the theoretical yield of a product. In other words, it is very unlikely that you will produce the maximum amount of product when you are in a lab. And it says, what are some reasons why? So think about it. If we were in a basic everyday lab setting, especially in a high school here, there's all kinds of things that can go wrong. Maybe you have error in your measurement when you start. You don't get a precise or an accurate measurement, so your equipment could be kind of bad. Other reasons, when you solve the thing or you have to heat it up and there's some kind of reaction, you often lose some as a gas to your surroundings. So again, you don't end up with as much as you probably could have. And those are just a couple of reasons why. Like I said, there's all different kinds. All right, so before I show you the formula for percent yield, there's a couple more things that I wanted to discuss with you real quick. So whenever we do an experiment, the amount that we actually find is the actual yield. So what you calculate in the laboratory experiment is the actual yield. If we were in a classroom lab setting, like I said, we start with a mass of something. Whatever we get for that final mass that you calculate, that's the actual yield. And our actual yield is always less than our theoretical yield. So remember, the theoretical yield is the maximum amount of stuff that you can have. The actual is what you calculated, okay? And the reason why it's always less is we always lose some to our surroundings. We don't have the best equipment to measure everything in the high school lab, not a controlled environment, so we do lose some to our surroundings. All right, and then it says a chemist will always calculate how efficient an experiment performed is based on the ability to produce the maximum amount of desired product. So again, this is where we're going to calculate that percent yield. Now, obviously, that closer percent to 100, the more efficient your experiment is. Again, in our high school setting here, I'm not expecting you to get anywhere close to 100%. Okay, so let's take a look at the equation. And it says the percent yield is the actual yield divided by the theoretical yield multiplied by 100. Okay? So again, remember, the actual yield is what you calculate in the lab. The theoretical yield can be found by doing a mass-to-mass stoichiometry problem. All right, so let's take a look at an example of first finding a theoretical yield and then, of course, finding the percent yield. So the problem says silver chromate forms when potassium chromate is added to a solution containing 0.500 grams of silver nitrate. So we have to determine the theoretical yield of silver chromate, and again, the theoretical yield is just a mass-to-mass stoichiometry problem. And then B, calculate the percent yield of the reaction given the actual yield is 0.455 grams of silver chromate. So again, it gives us the actual yield, like that's what we would have solved in the experiment, okay? So before we can do any of this, the very first thing in all of these stoichiometry problems is to write the equation. So it tells us that silver chromate forms when potassium chromate is added to a solution of silver nitrate. So we have potassium chromate plus silver nitrate, and we see we have two compounds, so it should tell us that's a double replacement reaction. So again, we have our potassium chromate plus silver nitrate, And one of the products it gave us was the silver chromate, which is that first product. And then remember, because it's a double replacement, the other product we're going to have is going to be the potassium paired up with the nitrate. Okay. After we have the equation written out, we have to balance that equation. So if I go ahead and do that, you can see that I need a 2 in front of the silver nitrate and a 2 in front of the potassium nitrate. All right, so now I'm ready to go ahead and solve my problem here. So it says determine the theoretical yield of silver chromate. Now remember, whenever we're doing theoretical yield, we're going to go from the given mass, which is the grams of silver nitrate up here, to a mass of what it is asking, the silver chromate. So again, we have silver nitrate, we're going to a mass of silver chromate. All right, so I've already set my problem up and I've worked out everything here. So you can see we start with silver nitrate that's given in the problem. We're going to divide it by its molar mass. After we divide by the molar mass, we do a mole to mole ratio. And then after we do that mole to mole ratio, we go from mole to mass of the thing that we're looking for. All right, so we go ahead and solve that out. When I did, I got 0.488 grams of silver chromate. Okay, now remember, this is the theoretical yield. All right, we just didn't call it theoretical yield the last couple of days when we were doing mass-to-mass stoichiometry. But from now on, whenever we do that mass-to-mass stoichiometry, just think it's we're solving for that theoretical yield. Okay, so part A is done. Now, part B, it says calculate the percent yield of the reaction given the actual yield is 0.455 grams. So, remember our equation, actual yield divided by theoretical. And all we have to do is plug in our numbers. The 0.455 grams of silver chromate comes from the number in part B. Okay, so just look above and you can see where I got that from. And then we're going to go ahead and divide out by the 0.488, because again, that's our theoretical. Solve it out, and you should get a percent yield of 93.2%. Again, when you're doing these problems, guys, it is very straightforward. You have to find a theoretical yield first, which is very simply a mass-to-mass stoich problem. And after you find the theoretical yield, it will either tell you what the actual yield is by saying, so-and-so found this in a laboratory experiment, or if we're actually doing a lab in class, it's the final mass that you get after you weigh your final product.